Dear students, welcome to the chapter of chemical bonding, and we are in our theory session number 1. The chapter of chemical bonding, which we will be discussing in this theory session, will start off with what you have already discussed or learned in your class 10. Basically, it will be an introduction to what a chemical bond is. What are the types of chemical bond that you have already learned visually? The ionic bond and the covalent bond. So starting with the chapter, here we shall discuss firstly what is a bond. So in one sentence we can say that the bond is a force of attraction. So we can say bond is a electrostatic force of attraction. Now obviously the force of attraction will be between two particular particles or bodies, and in this it is the attraction between two or more atoms or molecules or substances or compounds or bodies which is responsible for the particular arrangement of the entities or substance giving certain shape to them. So bonds are there in a molecule giving shape to that particular molecule. So we can say what is a chemical bond. In short, we can say atoms combine with one another to form molecules. And the attraction between any two atoms which holds them together in a molecule is known as a chemical bond. So this is the definition of what is known as a chemical bond. Now if we move to the chapter, we will find that there is a differentiation of chemical bonds, or what kind of chemical bonds are there. Chemical bonds can be further subdivided into, as we can see, an interatomic bond and an intermolecular bond. So if the force of attraction is between two atoms of a molecule, we can term this to be a interatomic bond, and if the force of attraction is between two molecules or two different molecules, we can term that to be a intermolecular bond. Interatomic bonds are subdivided into three main heads, that is the electrovalent bond, a covalent bond, and a metallic bond. Similarly, intermolecular bond is subdivided into hydrogen bond and van der Waals bond. Covalent bond, which is a subdivision of the interatomic bond, can be further divided into a polar, a non-polar, and a dative bond, which is known as the coordinate bond. So these are the differentiations of a chemical bond. The obvious question now arises that why do atoms combine, or what is the cause of the chemical combination? So if we move on to the chapter, we shall find that the first theory which explained the cause of the chemical combination was the electronic theory of valency, or the Lewis-Cossel approach. The Lewis-Cossel approach said that the atoms combines only to complete their respective octet. So completion of this octet was the prime driving force for the formation of any kind of chemical bonds. What is an octet? Octet is having 8 electrons in the valence shell. Further, we can also see that noble gas, which has configuration like this, NS2 NP6, or they have a completed octet, do not combine very easily. They do combine, xenon compounds are also known, but they only combine under very high temperature or pressure. Normally, if the octet is complete, therefore noble gas do not combine readily. Causal approach, which we have discussed now, is mainly based for inorganic compounds, while we will be studying about the Lewis approach, which is mainly based upon organic compound. So two theories that are there, that is the electronic theory of valency. The causal approach is basically for the inorganic compounds, and the Lewis approach is for the organic compounds. So after this theory, that is the electronic theory of valency, also known as the Lewis causal approach, we shall now move on to the theory which says that there is a tendency to acquire a minimum energy, or when a bond is formed, the system tends to attain a minimum energy. There is a relationship that says that stability is proportional to 1 by energy. That means if energy is low, stability is high. Now consider this particular system, that is, a water is stored behind a dam. If it flows down in order to attain a position of lower potential energy, then the dam attains a stability. In case of electrons which are there during the formation of bonds, we can say that as the distance between the electron and the nucleus decrease, the force of attraction between them increase, which leads to the decrease in energy. Conversely, a decrease in attractive forces increases the energy. So we can say that distance between nucleus and electron decrease, force of attraction increases. As the force of attraction between them increases, the system becomes more and more stable. So the two theories which leads to the formation of any kind of chemical combination is the electronic theory of valency, or the Lewis causal approach, and also the tendency to acquire a minimum energy, which says that stability is inversely proportional to the energy. So first discussion which we will have regarding our chapter of chemical bonding is the electrovalent bond or the ionic bond. According to the definition, as we can see that an ionic or electrovalent bond is formed by the complete transfer of electrons from the valence shell of one atom to the valence shell of the other atom. In this case, we can say that number of electrons lost or gained during formation of bond is known as electrovalency. So we have learnt about electrovalent bond, what is the electrovalent bond, and ultimately what electrovalency is, which is the number of the electrons that is lost or gained during the formation of the bond. Now, if there is a loss of electrons, there is a formation of a positive charge. If there is a gain of electron, there is a formation of negative charge. Therefore, we can say that there is a formation of cations and anions and the electrostatic force between the oppositely charged ions tends to decrease the potential energy. This electrostatic force is known as the ionic bond. So therefore, we have now known how does the formation of an ionic bond arise. There are a number of conditions or a number of factors that are helpful for the formation of an ionic bond. Firstly, the total number of electrons lost by an atom is equal to the total number of electrons gained by another atom. So if I consider sodium chloride as my example, sodium chloride is formed by Na plus ion and Cl minus ion. So there is loss of one electron by the sodium to form the Na plus ion, and also there is gain of one electron by the chlorine to form the Cl minus ion. So the first condition, that is the total number of electrons lost by an atom is equal to the total number of electrons that is gained by the other atom, is fulfilled. Also, there should be a low ionization energy. Low ionization energy in the case of the metal atom, in this case sodium. Low ionization means it should easily form the ion Na plus. There should also be a high electron affinity in case of the non-metal, in this case chlorine. That means it should readily form a Cl minus. So two things are very important. One is the low ionization energy and the high electron affinity. There should also be a high lattice energy. High lattice energy means the potential energy after the formation of the bond should be very low, or there should be energy that is released during the formation of the bond, which will give the stability to that particular electrovalent bond. Lastly, we have the strength and the stability of the ionic bond is proportional to the size of the ion, which is proportional to the charge of the ion. That is, strength and stability of the bond is proportional to 1 by size, and which is proportional to the charge on the ion. So these things, these 5 particular points, that is the total number of electrons gained by or lost by one atom, should be equal. The low ionization energy should be there. There should also be a high electron affinity. High lattice energy should also be there, and the strength and the stability of the ionic bond is proportional to 1 by size of the ion, which is proportional to the charge of the ion. So these are the conditions of ionic bond formation.